Good afternoon, everyone, and welcome to our presentation on near real-time analytics with InterSystems IRIS and Debezium change data capture. My name is Herman Bruwer. I'm a sales engineer from InterSystems South Africa. You probably recognize the voice, but with me I'm joined with my colleague Reven Singh, also from InterSystems South Africa. Today we're going to talk about how you can use IRIS data platform to get a near real-time view of your data across multiple source systems. We're going to touch on sort of what CDC is, sort of the benefits of CDC, some of the limitations of CDC. Then we're going to give you a quick demo of CDC in action, and then we're going to show you a near real-time view across multiple source systems using CDC. Lastly, if you can maybe keep your questions to the end, then we'll gladly answer them at the end of the session.
All right, thank you, Herman. Can you guys hear me okay? Great. Okay, so to present to you today, we're going to be doing a bit of role play. Well, Herman's going to be doing a bit of role play. I'm going to be myself, an InterSystems sales engineer. And Herman's going to play the role of a tech-savvy company executive at a financial services company.
Excellent.
So he's been looking into CDC, and he wants to understand if it's something that can help him with his time and attendance use case, as well as his financial transaction fraud. So Herman, why don't you get into character and let's begin.
Thanks, Reven. Okay, let me put my glasses on. So yeah, so what I understand from CDC, it is about identifying changes on data and then streaming these changes to a downstream process or system. Reven, can you maybe elaborate on what CDC is?
Absolutely. So capturing changes as they happen in a source database and replicating those changes to a target database helps you keep your systems in sync. And you might want to do that for various reasons. So some of the common reasons why you might want to do that are for disaster recovery or DR, but also quite commonly or popularly for analytics purposes. So if you are using IRIS and your source systems are built in IRIS and you're using IRIS BI, then you already have access to your data in near real time. But if you're not using IRIS and your source systems are built in using databases outside, then CDC is a great way to unintrusively listen to changes on those databases, capture those changes, and bring them into IRIS and use IRIS BI to get a view over your various systems on data as it changes. And you can do this without changing those existing source systems or without having to rewrite anything in IRIS. So Herman, what's your current analytics approach?
Yeah, well, we use ETL. So in order not to bring down the whole system, we normally run those processes at night. So at night, we run our ETL pipelines. And then normally, if all goes well, every morning I'll have a fresh dashboard.
Wouldn't you rather have a view of your business in its current state as opposed to having like a daily view via your ETL processes?
Yeah, sure, because ETL is by no means in real time. It's a really slow way of getting data, and hopefully change data capture would sort of come to the rescue.
Yeah, I absolutely do agree with that. I think using CDC, you can capture even the tiniest changes in your source system as they happen, and you can replicate those changes into IRIS for your analytics needs. And because this is happening in a near real-time manner, it means that you're not looking at data from yesterday, last week, or perhaps even last month. And because of this, CDC then brings many benefits over the traditional, conventional batch loading type of ETL pipelines.
That's interesting. Reven, can you maybe elaborate on the benefits of CDC?
Absolutely. So for one, it eliminates the need for continuously loading batch data or data in bulks. And the reason for this is because CDC allows you to adopt a more incremental approach where your target database is, again, incrementally kept in sync as changes are happening. In lots of cases, it's also unintrusive to performance, and this really depends on the type of CDC technology that you're using. For the most part, they tend to be log-based, and what that means is it tracks changes to your database transaction logs as those changes happen, as opposed to actively querying the database. And what that translates to is a very minimal performance impact on your actual database. It also supports near real-time analytics, and this is particularly true if you use this in conjunction with a platform like InterSystems IRIS data platform, because that's built to be able to handle data in this manner. You can use it to synchronize data across distributed systems. And also, because it's an efficient way to move data, it makes it a great option for on-premise solutions as well as cloud-based solutions. And lastly, it works well with stream processing solutions, such as Apache Kafka.
Well, that's interesting, Reven. Surely there should be some pitfalls there. Everything can't have just benefits. What are the limitations we need to watch out for?
Well, that's a great question. So your data volume and velocity. If you're working with really high volumes of data that's coming in at a really high velocity, then you'd want to ensure that your system or your infrastructure is sized accordingly so that it can handle this kind of volume and velocity. Now, in addition to that, you'd also want to ensure that your network can cater for streaming data and that whatever latency requirements you have can be met by your network configuration. So with regards to data consistency and integrity, CDC tends to be very event-based, which means that it's quite important to ensure that you have a highly resilient interoperability mechanism that will allow you to bring in these volumes of data and that will guarantee message delivery. Now, as time goes by, our businesses tend to change, databases tend to change, tables tend to change. And we commonly think of this from a database perspective as like schema evolution. And it's important to ensure that from a CDC solution perspective, it can also handle schema evolution. And with regards to security and compliance, since CDC is moving data or replicating data, it means that there's laws that would need to be adhered to. These might be data privacy laws, they may be industry-related laws, but ultimately what that usually translates to is that you may need to implement the right levels of access controls, encryption, auditing, etc.
Great stuff, great stuff. So Reven, can you maybe show us a simple demonstration of CDC in action?
Sure. So what I'm going to show you is CDC in its most basic form, and to do that we're going to simulate transactions happening in a source system, and we're going to and what we're hoping to see is as these transactions happen in a source system, we want to replicate that data into IRIS using a CDC mechanism. Now, to simulate the transactions happening in a source system, I'm going to do this in a really simple way. So I'm using a MySQL database that represents the database for the source system. And I'm just going to insert a bunch of records in there. And again, what we're hoping to see is as I insert the records into the MySQL database table, that's going to pull across into IRIS. Okay, so to do this, I'm using MySQL Workbench. And again, I've really just got like 1,000 records that I'm going to insert into here. But before I do that, I just want to speak a bit about the table structure. So in MySQL, I've got a table called ta.load. And effectively, in IRIS, I've got a corresponding table that has the same schema. And we're going to receive that data, and it's going to reflect in IRIS. So let's go ahead and insert these records. OK, let me show you one more thing before I do that. I want to show you that this table is empty. So right now, there's nothing in here. And we see there's a count of 0. And let's go to IRIS. Okay, not the best resolution, but here we see I've selected count from ta.load, and we've got no records in there as well. So let's go and run the bulk load. Okay, so while that's running, let's just quickly go back into IRIS and run this count again, and let's see what happens. Okay, so we see there's now 1,000 records in IRIS. Now, just to validate that what we've done is what we think we've done, if I go back into MySQL, and let's just pull the top 10 records. All right, so I see I've got a bunch of records in here. Let's just do a quick comparison with what we're going to get from IRIS. And let's run that. Okay, so we're seeing the same records. And I think at its simplest, what this outlines is that we can indeed capture changes as they happen in a source database and replicate those into IRIS, which describes CDC at its most basic.
Awesome, awesome. So yeah, so we've seen sort of 1,000 records replicated. Maybe Reven, can you show us the nuts and bolts of exactly how you did this?
Yeah, absolutely. So at the heart of the solution is InterSystems IRIS data platform. And this is coupled with a technology component called Debezium, which I'll describe shortly. So IRIS, I mean, that's something you're pretty familiar with. IRIS is a great place to manage your data, to integrate your systems using IRIS interoperability, and to perform analytics using IRIS BI. Debezium is an open source technology, and it's supported by Red Hat as part of Red Hat integration. Now, Debezium allows for database row-level changes to be captured, and they're captured as events, and we'll speak a bit about what these events look like in a bit. But effectively, these events can be published to a Kafka topic, and that's the usual way that one would use Debezium. But the other way that you could use it is to consume these events via a Java API. Now, just a point worth noting, Debezium is not the only CDC technology available. There are others like Oracle Golden Gate, Click Replicate, and a host of others. I like Debezium because it's quite flexible to use, especially when using it via Java API. Now here's a high-level view of what the solution that we've just ran looks like. So so down here we see a bunch of databases. So I've used MySQL, but Debezium supports many databases that you might be familiar with, such as SQL Server, Oracle, there's MongoDB, and it supports a bunch of others. And what we're doing is we're using the Debezium engine as a Java application, and that's running in the Java gateway. And then we're using IRIS to access this. Now, in this scenario, Debezium was configured to listen to changes happening on the ta.load table. Those changes were then captured as events and then sent to an IRIS production. And the events in that production were then consumed, and they were used to synchronize the corresponding ta.load table that lives within IRIS.
Great, great. But how does this translate to near real-time analytics?
Right, so now that we've got these tables in IRIS that are synchronized with the tables that exist in the source system, what that means is that we can now model and build cubes that are based on these tables. And these cubes can update in near real time. So we can then build dashboards that are based on these cubes, either in IRIS BI or using third-party BI tools such as Power BI, Tableau, etc. And since the cubes update in near real time, it means our dashboards will update in near real time as well.
Well, that sounds great. I've got a use case. I've got a time and attendance system that I need to get some insights from. And hopefully you can help me with that. So I can't poll the database every second to get real-time information. And because that will void the usage agreement, and it will also bring down the system. So the provider does provide an export functionality at extra cost. So I can export the CSV files and import the CSV files, but I mean, it's not real time. Will CDC be able to help me solve my problem?
Right, so usually what would happen is you might have an application that might capture security card data or perhaps biometric data like fingerprints to authenticate you. But ultimately this data would persist as a record in a table. So what we want to do then is we want to simulate this and see how CDC can help us capture that data and display it in a visualization in near real time, showing us who's in the building. So what we have is, all right, so we have a dashboard called employees in the building, and it's empty because there's no employees in the building at the moment. And what we want to see is, so we want to simulate the event of you, Herman, entering the building. And as that hits the source system, we want to bring that into IRIS, get that data into a cube, and we want to see this dashboard update to show us that you are now indeed in the building. So I know it's not a very pretty dashboard, even though there's nothing on there yet, but the point was really more to outline the near real-time flow of it all. IRIS has some really good BI capabilities for dashboarding and visualizations, but we really just want to look at the CDC bit of it. Yeah. So let's simulate that event. Again, in the MySQL workbench, I've got a table called ta.event. And I'm just going to insert a record in here that represents you entering the building. So if I run that, right. So I'm just going to select from this table so that we can validate that the record is now in the MySQL database and we see it's in there. Okay, let's go and see what this looks like in IRIS. Right, so in IRIS we see that the record's pulled through as well. Now the next thing that I've done is I've got a cube that's based on this table, and it's a really basic cube. There's a few data elements, and I apologize for the resolution. Let's see if I can. Does that look a bit better?
Yep, good.
All right, so I've got a few data elements in there, and we can then go and this is using the architect that's also part of IRIS BI that allows you to model and build cubes. So then using the analyzer, I can view what's in the cube, and we see there's one data element in here, and just to validate that, I can go in and drag stuff in my rows column, and again, I see I've got one Bruwer, which tells us that this has updated the way that we want it to. Now, if I go back to my dashboard, we can see that that's now updated to show me that there is indeed someone in the building, and if we look into the details, it tells us it actually is you.
Okay. Well, that's great, Reven. So we can definitely see that an insert is working. In our use case, in our system, we would actually, when you leave the building, update that same record. So how will an update reflect?
All right, so again, let's simulate that by, in the MySQL table, we'll update the record of you entering the building. And what we're going to do is we're going to update the record to put a timeout that indicates that you've now left the building, and we want to see that dashboard then update in near real time to reflect that there's now no longer anyone in the building again. So to do that, let's go back and run a SQL statement. This time it's an update statement. Okay, let's validate that that's what we want it to look like. So we see that the timeout is now part of that record, and if we go to IRIS, we want to see that that's also pulled through. So if we just rerun the select statement, right, we see that on IRIS the timeout is also pulled through.
Oh, awesome. Okay, so we've seen, but hold on, what will happen if I delete that record? What will happen on a delete?
All right, so if you delete it, then that's going to reflect as well. Now, just a bit of context on there on how this is working. In our IRIS production, we receive the inserts, updates, and deletes as events. So we've got a business service and a business operation. In here, the service listens for changes that Debezium captures, and then it takes those changes as JSON messages, which I'll show you in a bit, and it uses those to synchronize the corresponding table. But ultimately, what this means is once the message is in your production, you've got the flexibility to use this in a variety of ways depending on your use case. So you could send this to downstream systems. You could really do whatever you like with it. So just to show you what the message actually looks like. So if I go to the message viewer and, right, there we go. So this is the update statement we just ran, and this is what Debezium captured, and it tells us this is the record before the update and after the update. And before the update, we see that there wasn't any timeout. And after the update, there now is a value in the timeout field.
Okay, great.
All right, but anyway, back to your dashboard. So we want to see that this should have updated. All right, so it tells us that after you left the building, there's really no one there.
Okay, so we've seen that CDC can really solve simple problems. So sort of one table. Will it be able to help me with my other sort of use case, problem case? I've got a number of financial systems, and and I need to get some insights on those systems. The one system is a teller system, the other is a mobile app for the bank, and thirdly, we've got ATMs. And I've been plagued by some fraudulent transactions, and what I would like to do is get sort of a time distance between these transactions, and then use that distance to calculate if a fraudulent transaction happened. Do you think CDC can help me with that?
I do. Why don't you tell me a bit more about the kind of scenario that would exist in?
Yeah, so the scenario I would like us to test is that firstly we onboard a customer, and then the customer do a couple of transactions at the teller, then maybe do a transaction on the mobile app, and then say 400 kilometers away, a transaction on an ATM happens. Now that should be absolutely fraudulent. You've just issued the card. I mean, so that's really the scenario I would like us to test.
All right, so that sounds like a really interesting use case, Herman. So effectively what we're saying then is we want to run a couple of transactions, and based on the coordinates, the location coordinates and the time between transactions, we want to be able to flag using data from various different source systems, and looking across that data, we want to be able to flag as those transactions are happening, could they be fraudulent or not. Now, what we want to do then is we want to be able to see this visually somehow. So we've got another dashboard. And again, this is empty because we haven't put any data in here. But if a transaction is flagged as fraudulent based on some rules that we've applied to the data across the systems, we want that to show up in here. Now, to simulate the different source systems, I'm going to again use MySQL, but effectively this could be whatever it is your source systems are using. It could be SQL Server, it could be Oracle, it could be a combination of databases. Right, so going back to your scenario, let's now run a few SQL queries to simulate that. So the first thing we're going to do is onboard a customer. Now to do that, we just we inserting some data into a customer.demographics table that's part of your onboarding system. So I'm going to run that. Now I could again show you that this reflects in IRIS, but I think you get the point on that. We just want to see ultimately how we can look across data from the different databases. So we're going to create an account for the customer. All right, now on the teller system, we're going to now, sorry, I'm just trying to expand this a bit. All right, so now your customer goes to a bank teller and decides, well, I want to deposit some money. So we're going to run a transaction where the customer deposits $1,000 into their account. So let's run that. And again, since we're just trying to create a bunch of transactions here, let's say your customer then decides he's now going to withdraw some. So he withdraws $100 also at the teller. Right, so at this point, we've used two different systems, an onboarding system and a teller system. Now, on your mobile banking channel, let's say the customer then decides, I'm going to transfer $50 to someone. And let's run that transaction. Okay, now here's where the interesting thing happens. Very far away, over 400 kilometers away, like you've mentioned, at an ATM, a transaction is attempted. Now, this is clearly fraudulent because we just created the customer's account. The only card was just issued. There's no way this could have happened in the way that it did. So let's run this. And since this is clearly fraudulent, we want to see this dashboard update to show us that. And you'd see that, you know, as the transactions were happening, there was some intelligence running, and it does indeed show us that there is a fraudulent transaction. And if we look at the details of this, it tells us in less than a minute, over 400 kilometers away, this was attempted, which means that reasonably one would have to be traveling at a speed of over 25,000 kilometers an hour.
Yeah, so just to recap, Reven, so what we've seen is many different systems on different databases, a MySQL database, though that data being streamed to IRIS, and then doing some intelligence on the data, doing analytics on the data, all in near real time. So I think, in conclusion, you don't need to rewrite systems to sort of realize the advantages of IRIS and IRIS near real-time analytics. You can leave your sort of the systems in place, and then sort of using InterSystems IRIS and the Debezium CDC, you can stream those changes to IRIS and do the analytics you require. So we are quite keen to hear all your use cases. Any questions from the audience?
Yes.
Yeah.
Hi. Question on the Debezium use cases. I was trying to look online. So I see it, we're pulling from a common RDBMS to IRIS. Question, if I have two IRIS applications and I want to do CDC from IRIS to IRIS, can we use Debezium for that? Or is there a different solution?
No, so Debezium currently is built to work with a number of databases, so we can pull data from those databases into IRIS. But from IRIS, I mean, you know, we can look at some of the native mechanisms, so things like asynchronous mirroring, to mirror the data that's happening in your IRIS instance in another IRIS instance. So in that kind of scenario, you could do that. It's just that Debezium wouldn't be the thing that you'd be using to achieve that in that kind of.
Okay, thank you.
Sure.
Any other questions?
So let's say I wanted to go into IRIS first and then into MySQL. Could I use Debezium for that?
No. So that's something that Debezium wouldn't be able to help with. But I think, you know, that's a really interesting use case. So doing it the other way around. So what the scope of what we've been looking at is how do we use IRIS and its near real-time capabilities to really serve as an analytics server, an analytics platform, and consolidate your data from your various source systems and be able to access that in near real time. I think it would be interesting to look deeper into, maybe doing it the other way, but right now that's not something that we've done yet.
Yeah, the use cases, I think 7 different backend cache databases, one BI that's not in IRIS that they want to keep updated. I'm like, well, could we use this to update that external BI like we were discussing? So that's a use case.
Okay, thank you.
Yeah, I think maybe from our side, how we got to this demo is that usually in companies, they would have hundreds of different applications. And wouldn't it be sort of nice to get sort of a simple solution to stream some of that data into an IRIS to do analytics? So hence the time and attendance. So, I mean, the average company really have a lot of different odd systems out there. And the beauty of it is you don't need to rewrite any of those systems. You don't need complex ETLs or anything. You can just listen to specific pieces of information, stream that to an IRIS and do your analytics centrally.
So I think the question I'd like to ask then is, based on what you've seen here, are there any use cases that you think you might have that this might be able to help you with? Because we'd love to hear about that and kind of iron out what some of the kinks might be to get that to become a reality.
Yes, thank you very much. That was very interesting. I just want to get back to the first question that was asked and the use case from IRIS to IRIS or cache to IRIS. Whether you've done any investigation around that at all, because that is a use case typically to answer your last question that we have. We've got disparate databases, but all in the either IRIS or cache environment to be consolidated in an analytics platform. That's the one question, if there's anything more specific around that. And then secondly, is Debezium, the magic really seems to live in Debezium and trying to, it understands the differential as it carries on. Is there no interface from the IRIS side to feed those kind of CDCs? And is it a difficult product to use? How easy is that installation and that deployment and setup? Thank you.
Thanks, Gerrit. You want to take the first question, Herman? I take the second? Or I mean, up to you.
Yeah, that's fine.
All right, so to the first question, with IRIS mirroring, you could do synchronous or asynchronous mirroring. So your synchronous mirroring is usually more associated to things like high availability. But if you were looking at synchronizing changes in this kind of manner, you would probably want to look into asynchronous mirroring. So create a mirror pair and you have an asynchronous member that you might want to use for analytics. And that would then also receive the data as it comes. And if you've got your analytics built based off that, then that's potentially a way that you could achieve that in an IRIS to IRIS manner. From a Debezium perspective, I mean, the way that currently works is really with a number of databases. So right now, I think it's MySQL, SQL Server, Oracle, there's Postgres, MongoDB, and there's about 3 others. So if you're using any of those, then Debezium is a good way to bring data from that into IRIS. In terms of how easy that is to use, it depends. If you've got the skills available to use the Debezium engine in a Java application, great. I mean, a very basic thing didn't take me that long, but again, this is a demo. So in a production environment, there's other things you'd wanna look at. But also, Debezium more natively is built to work with Kafka Connect. So if you're using Kafka Connect along with Debezium, then what that translates to is you would then post through a configuration file to Kafka Connect, including the details of what you want to connect to from Debezium. And that's saying this in a fairly simple way, but that's the crux of how you would use it with Kafka Connect. And then what would happen is as changes happen, we've pulled them into an IRIS production, but if you're doing it that way, it would then end up in a Kafka topic, and then you could still use an IRIS production to then consume messages from the Kafka topic. So those are effectively the two ways, but using Kafka and Kafka Connect, if you're not already doing that, then that tends to be quite a costly option because standing up the infrastructure as well as the learning curve to be able to use these things can become a bit costly. So that's why this was positioned more towards how do you do this without incurring that kind of cost and just keeping it within IRIS.
I mean, in a simple way, it's really monitoring the journal files and replicating the journal files, almost similarly to what we do mirroring as we do. It's just that the Debezium doesn't have sort of the logic to pass our journal files yet. So it might be up to InterSystems products to decide whether they've got the appetite. I think a lot of that also depends on sort of the use cases out there. Is there demand for something like this? Then maybe it would be evaluated. If there's not really a demand, then obviously, so hence any feedback would be appreciated.
All right, we have run out of time, but I don't see anyone rushing in. So if there is another question, I think we're happy to take it. Sure.
Well, first, I need to know what 25,000 kilometers per hour translates to miles per hour.
Yeah.
It sounds like Debezium is simply works with relational databases, right? And only certain ones. Well, couldn't you map globals to IRIS or map classes to IRIS globals, and then look at? Couldn't Debezium look at that as a relational database?
I mean, I'm sure. We have a similar mechanism that we use for data replication in your mirroring environments. Mm-hmm. It's not something we have done, but considering that the kind of mechanism we use is somewhat similar, I see that certainly being possible.
Okay, thank you.
Sure. All right, the rushing in is about to begin, so thank you, everyone.